welcome to Number Concepts. There are 6 videos in this playlist. They are types of numbers, factors of numbers, multiples of a number, prime factorization, powers and roots, order of operation. In this video, I will discuss types of numbers only. By the end of this video, the student should be able to define and identify different types of numbers. They should be able to find the reciprocal of a number, differentiate between square and cube numbers, differentiate between rational and irrational numbers. These are the 4 objectives the student should be able to do by the end of this video. These are the numbers we want to look into. We will discuss natural numbers, whole numbers, prime numbers, integers, squares, cube numbers, rational numbers, and irrational numbers, as well as finding the reciprocal of a number. So let's look into them one after the other. The first one is natural numbers. What are natural numbers? Natural numbers are all counting numbers. I'm sure in mathematics, if you want to count, you start from 1. So 2, 3, 4, 5, 6, 7, 8, 9, and so on and so forth. These are referred to as natural numbers. They are counting numbers. The next one is whole numbers. Whole numbers are counting numbers including 0. So let's have a set of natural numbers here. We have n to denote the set of natural numbers. You have 1, 2, 3, 4, 5, and so on and so forth. Then W to represent to denote set of whole numbers. Then the first one will be 0, 1, 2, 3, 4, 5, and so on and so forth. So the only difference between set of natural numbers and set of whole numbers is 0. So if you precede set of natural numbers with 0, then you have set of whole numbers. So all whole numbers are natural numbers including 0. The next one will be prime numbers. What are prime numbers? Prime numbers are numbers that have only 2 factors, or prime numbers are numbers that can only be divided by 1 and itself. So for that reason, they only have 2 factors, 1 and itself. Okay, so if you look at 1, for instance, it has how many factors? It has only 1 factor because it divides itself by itself. So it has only 1 factor. So that is why 1 is not a prime number. A prime number must have 2 factors. Then let's go to 2. Yes, 2 divided by 1 and 2 divided by 2. Okay, so 2 is divisible by 1 and is divisible by 2. So it has only 2 factors. Then we can say 2 is a prime number. Go to the next one, 3. So 3 is divisible. 3 is divisible by 1. 3 is divisible by itself. So, and there is no any other number again. That means 3 is a prime number. What about 4? So 4 is divisible by 1, 4 is divisible by 2, and 4 is divisible by itself. You can see that 4 is divisible by more than 2 numbers. So you have 3 here. So because of this, then 4 is not a prime number. So I'll just list the remaining ones. You have so you have set of prime numbers now will be 2. So we can list the set of some prime numbers now. You have 2, 3, 5, 7, 9 is not there, 10 is not there, 11, 13, 17, 19, and so on and so forth. All these numbers have 2 factors. Okay, so they can only be divided by 1 and their selves. Okay, so that is how to get a prime number. It must be exactly 2 factors. It can be less than 2 and it can be more than 2. Let's go to integers. integers are both positive and negative whole numbers, or integers are both positive and negative counting numbers or natural numbers including 0. So you have a set like this. 0 will be the separator between it will be the separator of the positive and negative integers. So you have 1, 2, 3, 4, 5, 6, and so on and so forth. If you like, you can show the positive sign, and if you like, you can leave it like this. You can write it as +1 or simply 1. Then if you come here, you have -1, you have -2, you have -3, you have -4, -5, and so on and so forth. So these are referred to as positive integers, while these are referred to as negative integers. Why 0 is neither positive nor negative. It's just a separator between positive and negative integers. So the next one will be square numbers. What are square numbers? If you multiply an integer by itself, then the result is a square number. Take for instance, you multiply 2 by 2, you have what? 4. So this 4 is referred to as what? Is referred to as a square number. Okay? 1 by 1, the result is 1. That means 1 is a square number. Okay? If you say -2 times -2, you still have 4. That means 4 is a square number as it was established here. You can take 7 times 7, you have 49. So that means 49 is a square number. Okay, so just take any integer and multiply it by itself. The result is a square number. So the next one will be cube numbers. Cube numbers, you can get a cube number by multiplying the number 3 times. Okay, let's say you have 1 by 1 by 1. So the output is 1. 1 is a cube number, just like the way we established the fact that 1 is also a square number. By the time you multiply by itself 2 times, you have 1. Then you multiply by itself 3 times, you have 1. So that is why 1 happens to be a square number as well as a cube number. So 2 by 2 by 2, you have 8. 8 is a cube number. 3 by 3 by 3, you have 27. 27 is a cube number. 4 by 4 by 4, you have 64. 64 is a cube number. Although you can also have 8 by 8, then it will be what? 64. That means 64 can also be a square number as well as a cube number. Okay, because if you multiply 8 by itself, you have 64. If you multiply 4 by 4 by 4, you have 64. For these two reasons, 64 could be a square number as well as a cube number. So let's take one more. 5 by 5 by 5, you have 125, which is a cube number. So the next one will be reciprocal of a number. How do we get the reciprocal of a number? You can easily get the reciprocal of any number by flipping the number upside down. Let's say you have 2 out of 5. If you want to get the reciprocal of 2 out of 5, you have to flip it. 5 has to go up and 2 has to come down. So in this case, you have 5 out of 2. So 5 out of 2 is the reciprocal of 2 out of 5. So in the same way, if you are given a decimal number 0.2 for instance, and you are asked to find the reciprocal of 0.2, yes, it's very possible. You just have to change it to a decimal number for a decimal fraction, which is 2 over 10. Then you will now flip it. It will give you 10 over 2, which is the same thing as 5. That means the reciprocal of 0.2 is simply 5. So this is how to get the reciprocal of a number. Next, we have rational and irrational numbers. What are rational numbers? Rational numbers are numbers that could be written in the form P over Q like this. Okay, so where Q is not equals to 0. So any number that could be written in form of a numerator and a denominator is referred to as a rational number. Then how do you identify rational numbers? So rational numbers could be traced to the following. One, you have counting numbers like 1, 2, 3 and so on, because you can write them as what? As 1 over 1, 2 over 1, 3 over 1. So for that reason, all counting numbers, that is, all natural numbers, are rational numbers. Then any terminating decimal numbers. So all terminating decimal numbers are also rational numbers. What are terminating decimal numbers? Take for instance, we have 0.2. This is a terminating decimal number because it terminates, it ends, it stops after the first decimal place. So we have 0.47. So this is also a terminating decimal number because it stops after the second decimal place. So this is how to identify terminating decimal numbers. So if you have any one of these, yes, you could write them as a fraction in form of P over Q, and for that reason they are rational numbers. Let me show you. 0.2 as a decimal fraction, it will be 2 over 10, which is the same thing as 1 over 5. So that means 0.2 is a rational number. Then any non-terminating but recurring decimal numbers. Take for instance now, if you have numbers like this, you have 0.4747. You can see that 4 and 7 keep on recurring. So then we need to put a sign of ellipsis here to show us that 4 and 7 keep on recurring. Okay, and another way you could write this is to say 0.47, then you put a bar over 4 and 7. So that bar tells us that 4 and 7 are recurring digits. Another way you can write this is to say 0.47, then you put a dot over 4, a dot over 7. So this tells us that 4 and 7 are recurring. These are non-terminating. What makes them to be non-terminating is the fact that they do not stop. And what makes them to be recurring is that we have repeated digits. Okay, so it could be 1 repeated digit, 2 repeated digits, 3 repeated digits, and so on and so forth. Decimal number of this type is referred to as a rational number. You can watch out for my videos on how to write non-terminating recurring decimal numbers as a decimal fraction. Okay, so the next one will be all fractions in the form of P over Q. So take for instance 1 over 2, 3 over 5, 7 over 9, and so on and so forth. Fractions like this are referred to as rational numbers. And the last one there is any root of a number whose result is a whole number. So if you have square root of any number, let's say square root of 4, if the answer is a whole number 2, then that means it is square root of 4 is a rational number. If you have square root of 9, to give you 3. If you have a cube root of 6 to 4, it will give you 4. So any root that gives you a whole number is a rational number. You can go to my channel and see a video on how to differentiate a rational number from an irrational number. It's there on my channel. You understand it better. Okay, so the next one will be an irrational number. Irrational numbers are numbers that could not be written in the form P over Q, so where Q is not equals to 0. So you cannot write an irrational number like this. It is impossible. So numbers like that are referred to as irrational numbers. Okay, some irrational numbers are constant. Okay, let me give you some of them. You have pi. This pi, is beyond 3.142. So 3.142 is an approximated value of a version of it. Okay, so let me write. I want to write many digits after the decimal point. So I have pi to be equals to 3.14159265358 and so on and so forth. So this sign of ellipsis here tells you that it continues like that. So for this reason, this is a non-terminating non-recurring decimal number. Okay, so another constant which is also an irrational number is Euler's number, which is denoted E. Okay, Euler's number, and it is given as 2.71828828482904 and so on and so forth. Okay, it is also a non-terminating non-recurring decimal number. For that reason, it is an irrational number. So the third constant I'm going to give you is called golden ratio, and is denoted with this sign. Okay, it is denoted by this sign, and the value is 1.61803398874 and so on and so forth. Okay, so this is also a non-terminating, a non-recurring decimal number, and for that reason it is also an irrational number. When you are working and you need to use any of these constants, the approximated value of it will be given to you. Take for instance, pi is always given as either 3.14 or 3.142. So that does not imply that pi is simply 3.142 or 3.14. So you are only giving the approximated version or value of it. Okay, so it's beyond that. So these three are constant irrational numbers. They are constants. Okay, so aside that, we can have non-terminating and non-recurring decimal numbers. Of course, all these constant numbers are also non-terminating and non-recurring decimal numbers. Okay, but we have others that are not constant. Okay, you can have, maybe you are carrying out a calculation and you have numbers like 0.478301246617 and so on and so forth like that. So this is an irrational number simply because it is a non-terminating and non-recurring decimal number. The second criterion is any root of a number whose result is not a whole number. It's not a whole number. If you have square root of 4 on the previous page, we told you that it will give you 2. That means square root of 4 is a rational number. But if you have square root of 5, it will not give you a whole number. Rather, it will give you a non-terminating and non-recurring decimal number. Okay, so for that reason, square root of 5 will be an irrational number. Square root of 6, square root of 7, square root of 8, square root of 10, and so on and so forth. Once you just punch your calculator and you have a decimal number, then you should know that the number under that square root or the whole square root is an irrational number. Okay, so that is pretty simple. Just like what I said earlier, you can see my video on my channel how to differentiate an irrational number from a rational number. You enjoy it better. It was well explained there. We are going to look into some examples now. We have the first one. You have 8, 9, 10, 11, 12, 13, 14, 15, and 16. Okay, so from the list of numbers, write down the square numbers. So 8 is not a square number. So 9 is a square number. We go again. Which one again? 16 is a square number. Okay? Then here, the B part of it, we are asked to write a prime factor of 99. So we have not covered this one, so we're not going to talk about this. Okay? So in the next video, so we'll discuss something like this. So for now, we'll just keep this because we are yet to explain factors of a number. So we'll go to the next example. That will be example 2. So from the list of numbers, find a prime number. So here, you need to be very careful. If your better understanding of rule of divisibility will help you a lot. You have 210. Now let's see. Is it divisible by 1 and itself only? If yes, then it's a prime number. Otherwise, then it will not be a prime number. So we know from rule of divisibility of 2, okay? So by default, we know that 210 is divisible by 1 and itself, okay? So let me see if it is divisible by another number. Even though it is one number, then it is not a prime number. So let's see. From the rule of divisibility of 2, a number is divisible by 2 if it ends with 0. So automatically, 210 is divisible by what? By 2. So it's not a prime number. So I cannot pick this. Now let's go to 211. Okay, 211 is not divisible by 2. Why? Because of the last digit. Let's see if it is divisible by 3. You check. A number is divisible by 3 if the sum of the digits is divisible by 3. 2 plus 1, 3. 3 plus 1, 4. 4 is not divisible by 4 is not divisible by 3. That means 211 is not divisible by 3. So we keep on checking. Is it divisible by 4? No. Is it divisible by 5? No. Is it divisible by 6? So you keep on checking until you are able to show that it is not divisible by any other number apart from 1 and itself. So if you continue the division, you see that 211 is only divisible by 1 and itself. So I will pick this. This is 211. That will be my answer. So let's see if there is another one again. So 213, apart from 1 and itself, is it divisible by another number? Obviously, it's not divisible by 2. Let's check 3. 2 plus 1, 3. 3 plus 3, 6. 6 is divisible by 3. That means 213 is divisible by 3. So, of course, this one is 214 is divisible by 4. Of course, 215 is divisible by 5. And of course, 216 is divisible by 2. Okay? So, as well as 3. So, that means 211 is the only prime number there. Okay? Now, we want to get a cube number. So if we want to get a cube number, that means we must multiply an integer by itself 3 times. 1 by 1 by 1, you get 1. 2 by 2 by 2, you get 8. 3 by 3 by 3, you get 27. 4 by 4 by 4, you get 64. Then 5 by 5 by 5, you get 125. Then 6 by 6 by 6, you get 216. So if you check the list here now, you see that only 216 is a cube number there. So we'll pick 216. Okay, so let's go to the next example here. That is example 3. We have about 6 of them. So which of the following numbers are irrational numbers? Of course, this one is not an irrational number. So this one is not an irrational number. Look at this. Is this an irrational number? So it may, when you are adding two, let me quickly explain something. When you are adding two irrational numbers, the result may or may not be irrational number. Look at it now. We have root 3 here. It is an irrational number. And here we have root 6 here. It is also an irrational number. So if we add these two together, it will give us an irrational number. So I can circle this. But at times you could add two rational. At times, you could add two irrational numbers and the result will be what? It will be a rational number. Take for instance, you have pi, then plus 1 minus pi. Okay, so in this case now, if you add it now, pi, we cancel out positive pi, we cancel out negative pi. So the answer is what? 1. That means pi plus 1 minus pi. The answer is 1. And 1 is a rational number. Also, you could have root 3 plus 1 minus root 3. In this case, root 3 will cancel negative root 3. And the answer is 1 again. Okay, so you can see this is an irrational number. This is an irrational number. But when you add the two together, the answer is a rational number. This is also an irrational number. This is also an irrational number. But when you add the two together, the result is a rational number. So at times, when you add two irrational numbers, you could get a rational number, and you could as well get an irrational number. So if you are given any two irrational numbers, so you have to carefully look into them very well before you draw a conclusion that the result will be either a rational number or an irrational number. So you have to look into it very well. Okay, of course, this will be an irrational number, and which one again? This one is not, so this one is not. And let's see, 8 whole number 1 over 3, this is in index form, so you can write it like this. So 8 will be here and 3 will be here, then raised to the power of 1. So this one is a command, a number you multiply by itself 3 times and you get 8. What's that number? 2 by 2 by 2. That's what, that is 8. So that means the answer to this is 2 to the power of 1, which is 2. So 2 is a rational number. That means this one too is also a rational number. The only irrational numbers in the list are root 3, plus 6, and pi. Let's go to the fourth one. From the list of numbers, write down a cube number. So which one will be a cube number here? You have to check. Of course, it is not this. It can be this. It can be this. It can be this. It can be this, it can be this. So this is the only one we have left, and that will be our answer, although that is not sufficient enough. Okay, because what if this one too is not a cube number? So but I know 343 is a cube number, because if you multiply 7 by 7 by 7, so you will get 343. So that is why 343 is a cube number there. So which one is the smallest number? Which one is the smallest number here? So the smallest number will be a negative number. Okay, so you can see my videos on integers. Okay, so if you don't understand this very well, so you can see my videos on integers to understand this better. So the smallest one will be the it will be from the negative integers, of course, so there's no doubt about that. Okay, so between minus 7 and minus 11, which one is smaller? So minus 11 is smaller, so I'll pick minus 11. So just like what I told you, I've discussed this on my YouTube channel. Just check integers for year 7, you'll enjoy it better. Okay, then a natural number. So natural numbers are counting numbers. Okay, so the one that will be there is this 343. Okay, so we pick 343 again. Okay, that is the counting number. So let's go to the fifth one. That's example 5. P is the largest prime number between 50 and 100. Q is the smallest prime number between 50 and 100. Calculate the value of P minus Q. So we need to get the values of P and Q respectively. So P is the largest prime number. Of course, 100 is the largest number there, but it's not a prime number. We leave that. 99 is the next one, okay, and it's not a prime number. 98 is the next one, but it's not a prime number. I want to believe you know the reason. Then 97 is the next one, and 97 is a prime number because apart from 1 and itself, there is no any other number that can divide it. So I'm going to put 97 here. That's the value of my P. And Q is the smallest prime number. Okay, so let's start from 50. 50 is not a prime number. Then 51 is not a prime number. Then 52 is not a prime number. Then 53, okay, is the smallest. Okay, is the what? Is the smallest prime number there, because apart from 1 and itself, there is no any other number that can divide 53. So that means the value of Q would be 53. So we can now do P minus Q, and that will be 97 minus 53, and this will be 4 here, and this will be 4 here. So that means the value of P minus Q is 44. So this will be the end of this video. The next video will be on factors of numbers. You can watch out for that. Bye.